We're going to turn over to our next speaker. That is Dr. Shehata. Dr. Shehata earned his Ph.D. at the University of Waterloo in machine learning and natural language understanding. He did this a decade ago, where he developed award-winning research and authored patents. His research work is in the area of machine learning and artificial intelligence, and has been recognized and published in top conferences and journals. Before co-founding YOURIKA, and he's going to talk to you today about YOURIKA, Dr. Shehata spent a decade leading data science, business intelligence, and engineering teams at Desire to Learn, D2L, one of the world's most prominent learning software companies. So with that note, Dr. Shehata, I'm turning the talk over to you.
Thanks, Harold. Thanks everyone for attending my talk, and thank you so much, Institute, for pulling together such a great event. Can you see my screen? Can you hear me well?
Yeah. So it's a little dark on your face, but we can see that.
How is that?
That's a bit better. Yeah, there we go.
Okay. Yeah. All right. So today we'll be talking about our knowledge prediction engine at YOURIKA, and I would like to start with why did we build this prediction engine. So we'll start off the focus of personalized learning. Why do we care about personalized learning? We'll talk about the evolution of the personalized learning. It's important for the future of education and workplace learning, and we want to nail down the definition and see what is the main challenge here. Then I'll be talking about our knowledge prediction engine, which is YOURIKA knowledge prediction engine. We'll talk about the values that this engine is providing and how it can be integrated with any content provider. Then we'll be talking about, this is the why, the what, and talking about the how. Get more deep into the deep learning models behind the scene. What is the accuracy of the model? What is the experiment that we built in order to be able to come up with the models? And then we'll end up by the impact or the insights that can be generated by such a technology, and how this will have like a huge impact on the personalization for learning in general. So let's start with the why personalized learning. Before starting with it, let's talk about the evolution of the personalized learning. So it is not new. It's starting from 1800, 1900, and as you can see here, in 1800 there is a press search of Pueblo, Colorado. They allow the students to move at their own pace. So the learning, the personalization of personalized learning is starting from 1800, and it's also that not every student in this case has to do the same thing at the same time in the classroom. In early 1900, San Francisco Normal School, they promoted the students based on their mastery. For example, so once a student masters a grade level in a subject, he or she can move to the next grade level, which means that you can find the student in the 6th grade English, 9th grade science, and 7th grade math at the same time, which is very interesting that they have this kind of concept 1900. If we go further on the timeline, on 1916, John Dewey published his book Democracy of Education, and it detailed that learning should be centered around the student, learner-centric, and it should be departed from the traditional curriculum-centered teaching style. So take it more about learner and less about the curriculum teaching style. And he also argued that the students needs to be engaged in order to be learned. Otherwise, he will not learn. And this is 1916. If we continue with the timeline between 1960s and 1970s, there Fred Keller, he creates a personalized system of instruction, PSI, where the students learn to master the content and at their own pace and assessed at the end of each unit, which means that those who have mastered the material will move on to the next unit. Others must relearn the material and retake the test. Kind of like the test is the pass to go to the next level or not. Coming on the 2000s, and this is one of the major change, Dan Buckley credited with the defining personalized learning into 2 different forms in 2005. And this is very interesting one because it now have a personalization into two sides. The first one is personalization for the learner, which means that it refers to the teacher creating the learning experience for the students. So the teacher will provide the personalization to the students. And the second form is personalization by the learner, which means that the students acquiring skills to better adjust at their own learning. So one from the teacher side and one from the student side. And then from 2010 till now, as you already experienced, personalization learning has become a common part of school learning plans. Everyone is looking for personalization because they want to make the learning specific. There's lots of funding and professional development opportunities around personalized learning. And why this is happening? Because it's around from decades, and it will still be continue a major part of the education, but people are increasingly looking for this because they want the learning to be specific to them. Not everyone is learning the same way. Everyone has their own kinds of thinking and mental model, and they want to make sure that the learning is specific to their needs. So if we get very detailed around the definition of the personalization of personalized learning is, it tailors personal learning plans to the individual knowledge, skills, and interest and learning style of each student. So it tailors, it has to be very specific to my knowledge, my skill, my interest and learning style as a learner. And the question here is, if the personalized learning is already in like decades ago from 1800, why we don't see one system that is dominating? Or we know that this system is learning that we are looking for. Why we have this kinds of challenge on learning all the time? Everyone is talking about having personalized learning, but actually there is no system that is able to provide the experience that the learner is looking for. And I think the main challenge here is assessing the knowledge and the skill of the learner. We need an accurate way to measure my knowledge as a learner, because a learner, people don't know what they don't know. I don't know what I'm missing to learn about a specific topic. Maybe there are dependencies about this topic that I don't know about, and there's no way that I will know about it because I don't know about this topic. And recommending more material, if it is not fitting on my knowledge level, then we are not providing personalization. We're not providing personalized learning. So the main point here is, if we have a way that can measure the knowledge of the student or of the learner very accurately, then this is the root cause. Then we can start recommending what they are missing and what are the gaps in the learning. And this is the main reason that we built the knowledge prediction engine. I've been working in education for 10 years, and I was looking to build a system that can help the learner in the learning moment and help to provide the recommendation and the guidance at the learning moment. So what is the knowledge prediction engine? If we started, the knowledge prediction engine is providing kinds of like, it is the most important part is learner centric. So the main focus is the learner. We augment the teaching, we augment the help with the teachers, and it's a system that's focusing on the learner from the perspective of what they need. It can be looking at the learning gaps, topics dependencies, next generation of assessment and knowledge. So these kinds of like a 4-dimension that the knowledge prediction engine works on. Starting from the learning gaps, it can identify the user learning gaps in each subject and across topics. Like within the subject itself, what I'm missing in these topics, what is my level of knowledge in these topics. And in order to do that, it needs to know what are the dependencies between the topics in the subject. Like as you know and experience in learning any of the topics in education, there's dependencies between the topics. You can't learn you can't learn B before learning A. And you need to make sure that you have these dependencies right, otherwise you will read stuff and you'll say, where is this coming from? So the system itself inherently have these kinds of dependencies and be able to identify these kinds of dependencies between the topics. In order to say that this, like to judge or to assess or evaluate or measure if the student is able to understand, have like a knowledge about the topic or learn about the topic, this is kind of like a next generation of assessment. We definitely consider the questions and the answers and the assessment, but not only that. it go beyond the assessment from the exams or the questions. It look at learning activities, a video that a learner looked at, a discussion happened between the learner and their peers, a question or a session happened between a learner and their teacher. Every 360 activities that is happening by the learner are included into this next gen of assessment that help the knowledge prediction engine to identify what is the learning level and end up by measuring the knowledge. And this is the main goal and the most important part. It provides an accurate measure of the level of knowledge and measure of understanding for each topic. And if you see at all like the different dimensions here, the learning gaps at the learner side, topic dependencies at the content side, the next gen assessment is the evaluation side, and all of this will feed into measuring the knowledge. So this system and knowledge prediction engine, we have our own platform that this system is running on, which is Orbitz, but also this is not only included in our platform, it can be integrated with any systems in the market, because we want to make sure that we are powering education. We believe that this is one of the main value proposition that can help education to proceed further into the personalized learning. So our model can be integrated with learning management system. And there's multiple famous learning management systems like Dry2Learn, D2L, Canvas, Instructure, Blackboard, Moodle. So any content provider that have this kinds of content, the system is able to integrate with. Another option is it can also integrate it with publishers. And content publishers like the books, the school books, and the textbooks, like Cengage, kinds of content publishers. It also can be integrated with the student information system, which is usually the system that is responsible for registering students' courses, transcripts, grades. It can integrate with the information that's coming from the student information system and power these systems. At the end of the day, it can integrate with any content provider. If there's a teacher that created some kinds of content and would like to use the engine to be able to power their learner with having the engine that can deliver the content in a personalized way, this can be done through the engine. So this is in a nutshell what the predictive engine is doing. Let's go deep into how this works. So what are the deep learning models that created behind the scene? What kinds of experiment that we did in order to provide these kinds of results? So as you may know, intellectual property IP technology is based on years of experience in AI and deep learning. So we test and train our models against real existing data from real students. And this is real world data and multiple data sets from multiple customers. And I would show you in details what this data set looks like. Our main goal is to validate if our knowledge prediction engine could predict with high accuracy a student ability to answer series of questions correctly based on understanding of a topic. So when we provide a set of questions, if the student is able to answer these questions or not. And the system is looking at more activities happening behind the scene to be able to evaluate the learning or the knowledge of the student or the learner. So let's talk about our experimental methodology. What did we do? What is the data set? How we measure, evaluate the models? The idea is we have two types of data. We have number of topics and we have number of questions and their answers. And every time we're feeding the questions and answers to the model with the number of topics and see what the model will predict. And because this is historical data, we know beforehand what the results looks like. So a typical course content is around 100 plus questions, answers, and around 10 plus topics. And when I'm talking about like the course content, like calculus, for example, you have like 10 or 15 or 20 kinds of topics in the course. When we run our model, we got over 85% accuracy, and it reached over 90% accuracy, kind of like a range. And this is good. We found that this is starting with the typical course content, and the approach is we are increasing the data and see if this will impact the model or not. Then we take like a large course content, which means that we got over 100 plus topics, which is very large. If you think of any of the courses that you took in high school or in the higher ed, number of topics, 100 is big. Usually it's like less than that. And then the number of questions answered, we have like 120 question plus, and this could be increased, but the main focus on the number of topics. And we still have on the same range of 85 and 90% on the accuracy side. And at that point of time, we found that this is good. We have a good result after lots of experiment, and I'm going to show you how the MLOps behind the scene was working. But then we want to see if the model will hold if we try to introduce more noise to the system, which means that, yeah, it can work for each course, but what about if we start merging courses, merging subjects, and make the model try to identify the topics across subjects, which means that I can take a subject like English and a subject like calculus and put the topics with each other. Or I can take music and put it with physics. So it doesn't matter about the subject. It takes all the topics across all of the subject and feed it to the system and see how the system will perform. Usually, when this happens, we're talking about 20-30% accuracy of the common market systems. When we increase the number of questions from 10,000 questions to 50,000 questions, and the number of topics from 1,000 to 5,000 topics, we still have a decent results above 70%. This is not going to happen in any kinds of course. What we're trying to do is we want to make sure that what the model behavior will look like and what is the robustness and reliability of the model. And we didn't stop at that point. We take it further by adding more content and more content across subjects. So we reached to number of questions answers to 70,000 question answers. And we added the number of topics to over 8,000. And at that point of time, we're talking about like across I would say 50 to 100 kinds of subjects that we are adding together. And as I mentioned, this will never be a case of the course, but just to show that with this level of noise introduced to the system, the model is still able to be to identify the majority of the topics in each one of these subjects. The main one that we are using in most of our systems is like these ones with the large course content and the typical course content. But this kind of like the experiment approach that we did in order to make sure that we are looking for how we are calculating our accuracy. And this is the ACC and AUC under the curve accuracy. So from our perspective, the accuracy we found it like 85% to above 95%. And this is for the common course size from 10 to over 100 topics. Let's talk about how would this model take it from production, which is one of the very hot topics these days about machine learning operations, MLOps. And there is a history on MLOps that comes from the engineering side in CI/CD, continuous integration, continuous delivery pipelines. And all of this title is about, I want to click on one button to take the data from the customer, be able to have a model in production that is running. So I am taking the time to build the model, make the training, come up with the best model with the hyperparameters, and be able to have this model in production running properly and working with the product, which is a huge effort from only the engineering side, not from the data science side. And I have the privilege to work in both sides. So let's go through this kinds of journey. So start with the data pipeline, which means that looking at the data cleansing, transformation, management, analyzing the data, looking at if there is any bias in the data, the outliers, all of the data issues that you are familiar with. This will be part of the data pipeline to form the data in a format that can be digested by the machine learning pipeline. The machine learning pipeline will take the data and divide it, having the training, testing, validation, the crossover, fine-tuning based on the hyperparameters, because as you know, in the deep learning models, there are lots of hyperparameters based on the model as well, and based on the algorithm that you're using. And this is experimental, so you tried lots of different functions on the different levels of the neural network, and you see what the result looks like. And imagine that what's happening is the data scientists doing this on Jupyter Notebook and keep trying to change this manually and try to tease the result at the end. But in production, on real life, this is very hard and it's not going to scale. So we build a pipeline that can do all of this automatically in order to come up with the model selection. So this is automatic model selection based on the best results. This is the golden model and the best model that we can get out of all of these experiments, and we can use this model for the inferencing in production. So we take this model, deploy it in production, and monitor the model results as a feedback loop. Because once you have the model in the field, it is not the end of it; it's the start of it. You want to start looking at the results. If the model is behaving the way that it should be, we have like monitoring the model behavior and monitoring the model the results and making sure that what's coming and what's generating is exactly what we are looking for. So this is behind the scene on both the engineering side and from the experiment side on the model. Let's go to the impact. Okay, if we have this technology and we are very leveraged and very happy and proud about the technology, what did that mean to the education? What we can do with this kind of technology? What is the impact and what are the insights and analytics that can be generated? Being in education for 10 years, all institutions, teachers looking for if the students learned about the topic or not. Everyone is hungry about this kind of insight. And the insight that I'm going to show you here is get deep into the knowledge of the learner versus the engagement of the learner. And I'm going to show you the example here. So starting, suppose that I have two kinds of courses or subjects, programming and physics. I want to know what I'm doing in each one of these subjects. So the system will be able to identify for each topic into the subject. Here the subject is programming and the topics would be conditions, loops, recursion, functions. So it can give me a percentage of my knowledge level of understanding in each one of these kinds of topics. So in conditions, 50%, in loops, 82, 85%, in recursion, 60%, functions, 70%. And the same for physics. I'm not doing well if I'm the learner, 40, 35, 30% in vectors, forces. And this is this will give the learner the percentage for each topic, but also based on these numbers, we can get some kinds of percentage across the subject. So in the subject itself, you have 85% based on the topics or the percentage that's coming from the topic, and the same thing for the physics. This will give an instant shot of the percentage of knowledge for any subject and across topics into the subject. But we can also take it over time, which is very interesting as well. So you can see here on the 85, this is the learner progress in the week 1, week 2, week 3. And as you can see here, week 1 started to, like, the learning is increasing in week 1, week 2, and then in week 3 there's a dip here between in the programming course. And this is very important to identify why this happened, why this dip created. Is it personal problem? Is it because more content is provided that makes it more ambiguous? This kinds of analytics or insights is very important to the learning. And if we see a common patterns across all of the learner, maybe there's something wrong here. Maybe there's something on the content that needs to be updated. It's confusing everyone. And this level of insights and analytics on the learning, on the personalized learning, we don't see it before. So this is the first, to our knowledge, the best of our knowledge, the first system that can provide this kinds of deep insights on the student or the learner knowledge. The common analytics that you can see in the market is about engagement. If the student or learner is engaged to the tool itself. But this doesn't mean anything from the learning or the understanding perspective. Maybe the tool is cool, so people are engaged with it, but they don't understand the topic or the other way around. They understand everything and they are fully aware about the content, but they don't like the tool itself, so they don't engage with it. And this is the main value that we see that's coming from our prediction knowledge engine. The end goal of these kinds of analytics and insights is to come up with something like this. We're looking for a profile for the student knowledge. Emily Carlton, she's taking these kinds of subjects, physics, chemistry, calculus, biology, and the system can identify what is the percentage of knowledge in each one of these subjects. And as you can see here, calculus has 60%. So the system starts recommending more material to Emily that she'd be able to improve on calculus and increase her knowledge in calculus. And as you can see here, we are talking more about personalization that's based on the measure of the knowledge and solving the problem of measuring knowledge to be able to provide more personalization, more recommendation to the student. This can be applied to any kinds of system. So it can also be applied to a learner. So it doesn't have to be only students in education. It could be a learner in workplace, in a company. And there's a skills that I want my employees to be able to have. For example, here add more Flash, InDesign, CSS3, Photoshop. He's doing well on CSS and Flash, but InDesign and InDesign, but he's not doing well on Photoshop. In Photoshop, it's 55%. The same thing. We start recommending material that can help to augment the skills for the learner. So if you look at,
sorry to interrupt. We have about 3 minutes left.
Okay. So the last, actually, this is the last slide. So if we look at the deep insight that we are creating, we're creating at the level of the learner. So feedback about learning gaps for the learner and provide to teacher. So this kind of feedback will provide it to the learner, but also provided to the teacher and institution. We are looking at learning objectives. This is one of the most important questions: is that the learning objective of this course achieved or not? Can we report on this? And there is no accurate way to do this right now. On the content side, we can have a feedback on the content. If this content is, what is the difficulty of the content? If we see a pattern across the majority of the learner, this means that there is an issue on the content that needs to be improved. All of this reporting can be provided at the institution level from the learner content, learning objectives, and reports. So at the end, we believe that the knowledge prediction engine will have huge positive implications, personalized learning in the traditional education, workplace learning, and upskilling. And thank you so much for listening to the talk.
Awesome. Well, thanks. We have. I just want to do a call out here. And you say your name, Shadi?
That's correct.
Shadi's having one of the breakout networking booths. If you want to go visit there to ask more questions. So I'm going to put one question up for you. You know, learning such a broad topic. You know, so many from institutional learning to companies. Where's YOURIKA's focus? Where are you starting? Who are you trying? Who's your target? You know, first customers.
Yeah, feel free to come to the booth, and would love to get you all of the details around this.
Okay. Well, I'm gonna wrap up then. This has been a great talk. Thank you again so much for sharing, and thanks to all three of our speakers in this stream. Hopefully it was enjoyable also for them. And we look forward to continuing this open sharing and people, for our participants, to get their head around, you know, the evolving you know, landscape of AI and how things are moving forward. So again, thanks very much for your great day, and I'll leave it to our production assistant, to Sarah, to wrap up this session.